Coming back to section 7.2, I hope you guys were able to do this problem where you had to find the sine, cosine and tangent of negative 5 pi over 12. Now, it's not that easy when in radians how to write it as a sum or difference of angles in radians. Multitude of pi, right? And so what I did here, I converted the angle into degrees. Here in degrees it came out to be negative 75. Okay. Now I can think of 75 can be written as 30 plus 45. So negative 75 can be written as negative 30 minus 45. Now if I choose this one, if I choose this, then both angles have to have a negative sign, or at least I'd have to remember that I have to think of this as negative 30 and then minus 45 if I want to apply the sine of A minus B formula. So I would like one angle to be positive and one negative, so I rewrite and think that 45 can be written like this. So 75 can be written like this, negative 75. So I get pi over 4, then I convert it into the pi or the radian measure, and it becomes pi over 4 minus 2 pi over 3. Then I apply the formula. So sine of negative 5 pi over 12 can be written as sine of pi over 4 minus 2 pi over 3. And then apply the formula, plug in values, and I get my sine value. Similarly doing the cosine, and then the tangent is just sine over cosine. Okay, now we can work back. We can go opposite way. We know that if you remember that if you have both cosine terms, cosine alpha cosine beta, and then over here you have sine alpha sine beta, okay, then this will become cosine of alpha and plus or minus depending on what sign we have. If we have negative or minus plus, so if I have cosine alpha cosine beta minus sine alpha sine beta, then it will become cosine of alpha plus beta. And if I have cosine alpha cosine beta plus sine alpha sine beta, then it will be cosine of alpha minus beta. So here we have cosine cosine, here we have a negative sign, here we have sine terms. Okay, can you see this will be cosine of 10 plus 80, which is cosine of 90 degrees, which is 0. So instead of finding cosine 10, cosine 80, sine 10, sine 80, which we cannot without calculator, but if you know, you can do it like that. What about this one now? Now this is sine cosine, right? In both terms you have a sine and a cosine. So this is a sine alpha plus beta or sine alpha minus beta. What will tell us? This middle sign. This is negative, so I have sine alpha minus beta, means sine of 3 pi over 15 minus sine of minus negative pi over 5. So will give me sine of 13 pi over 15 plus pi over 5. The negative positive, so that we get 13 plus 3 pi, so 16 pi over 5. So I get 16 sine of 16 pi over 15. Well, we cannot simplify it further, we can leave it here. Okay, so next we look at let's look at evaluating expressions that are a little bit more complicated. So let's see if we are given this information that cosine of an angle is this, and where the angle is situated, and then there is another angle. We are given information about that, and then we have a information about the maybe another in which quadrant the angle is situated in both cases. So we have a trig ratio for both of them, and then we have a the quadrant in which they are existing. So this is like work we have done before, like a problem similar to this could be on the exam. So now what we do, we have to find sine of theta plus phi. So theta and phi are two different angles. Okay. So what we do here, so we start with like this: is that sine of theta plus phi is equal to sine of theta cosine of phi plus cosine of theta times sine of phi. So now if you note some of the things you know. So what do I know? I know this quantity, cosine of theta is 12 over 13, and sine of phi. So sine of phi, and we know this one is negative 4 over 5. What we need to know is these two. We want to know what is sine of theta and what is cosine of phi. So how do we do that? Well, we have done that in many ways, so you can do it however you want. I will do it with the triangle. So I will do it like this, the last thing that we saw in section 7.1. So I will say, okay, I have my theta angle is in fourth quadrant, so it will be somewhere here. So this is theta. So this is, we are given the cosine of theta is 12 over 13, which means this is 12 and this is 13. I need to find this side. Call it A. So A square plus 12 square is equal to 13 square. So A square plus 144 is equal to 169. So A square comes out to be 169 minus 144, which gives you 25. So A is 5, okay, but because it's in the net, it's actually plus minus 5, but it is in the downward, like in the second quadrant, and the y the y is negative in here. So this will be negative 5. Okay, so now if I know that, then I can find sine of theta. So therefore sine of theta is equal to negative 5 over 13, which I will plug in there. Okay, the second one, our quadrant angle is in this quadrant. This angle is phi, and what we know is that sine of phi is equal to negative 4 over 5. So 5 is the hypotenuse, negative 4 is the opposite. So this, so what is this side? So I call it B, let's say. So B square plus negative 4 square is equal to 5 square. So B square plus 16 is equal to 25. So B square is equal to 9. So B is equal to plus minus 3. But what will it be? So B is equal to negative 3, because it's in the along the negative x-axis. So we have now cosine of phi will be equal to negative 3 over 5. Now we come here, plug in So this becomes sine of theta. Sine of theta is negative 5 over 13. Cosine of phi. Cosine of phi is negative 3 over 5. We just found it. Plus cosine of theta. Cosine of theta is 12 over 13 times sine of theta, sine of phi, which is 4 over negative 4 over 5. Simplify this. So I get 3 over 13. Actually, you know what? I think I will keep I will not simplify it. Keep the denominator as it is, because both of them will have the same denominator, so it's easier to add them. So 65, 13 into 5. Up here I get 15 minus 65 and 14 4s are 48. Subtracted. 8 minus 5 is 3. And then 4 minus 1 is 3. So I'm getting negative 33 over 65. Okay, one more example like this. So now it's asking us to find cosine of theta minus phi, where this is the information about theta, this is the information about phi. So let's do this first. Theta is in the second quadrant. So I'll make a triangle, right triangle. This is my theta. And theta, sine of theta is 2 over 3. So this is 2 and this is 3. I need to find this. So what will it be? P will be equal to negative square root of I. So that I can write the cosine of theta. Okay. Now with the phi, the phi is in the first quadrant. And tangent of phi is square root of 7. So I can write it as square root of 7 over 1. So square root of 7 here and the 1 goes here. So I need to find this side c. So c square is equal to 1 square plus square root of 7 square. So it gives me 1 plus 7, which is equal to 8. So c will be equal to, now this is hypotenuse, so we will not take the negative sign, it will be just the positive one. So square root of 8, which means 2 into square root of 2. So that, okay, let's see what we need from here. Okay, so now let me move it over here just to save the space. So first we write the formula. So it will be cosine of theta, cosine of phi, plus sine of theta, sine of phi. So what we know, cosine of theta, do we know that? Yes, we have it. So negative square root of 5 over 3 times cosine of phi. Do I have cosine of phi? Well, I can find it. Cosine of phi is equal to 1 over 2 into square root of 2 plus sine of theta. Sine of theta is given, it is 2 over 3, and sine of phi. So this will be square root of 7 over 2 into square root of 2. So we get minus square root of 5 divided by 6 into square root of 2 plus 2 times square root of 7 over 6 into square root of 2. So it can be written as 2 times square root of 7 minus square root of 5 whole divided by 6 times square root of 2. So this will be your answer. Okay, now we are going to learn some more formulas here. So we are calling this identities, but both of these are special things, special kinds of formulas here. Okay, so first we have to verify that the left hand side is equal to the right hand side. So how can we do that? Notice here 2x, like 2x can be written as x plus x. I hope everyone agrees with that. So I'm going to write it as sine of x plus x. And now I'm going to apply the sum formula on sine. So sine of x cosine of x plus cosine of x times sine of x. So what is that? Both are same, so we get 2 times sine of x cosine of x. So now this became sine of 2x is equal to 2 times sine of x cosine of x. We call it double angle formula. Okay. Now cosine of 2x. So how can we do that? We'll apply the same technique that we did above with the sine. So we'll write cosine of 2x can be written as cosine of x plus x. So when you apply the formula cosine of x into cosine of x minus sine of x into sine of x, which becomes cosine square x minus sine square x. So if you note, this is the first identity we have proved. Okay. Okay. So now what about this one now? So we have to, so this is the same as the second one, and then this is the same thing as the last one. So from here I can go here, and then from here I can go there, or I could also go from here to there. It's your choice. Okay, I will write. So if you notice, we are now going to show cosine square x minus sine square x equals 1 minus 2 sine square x. So if you notice from here to here, on the left hand side we have both the cosine square x and the sine square x, but on the right hand side we have only sine square x term. So cosine square has vanished. So where did it go? So basically, if you recall again from the Pythagorean identity, we can use that, and we can get cosine square x in terms of sine square x, because remember the Pythagorean identity is, this is the Pythagorean identity, and now if I want to find the value of cosine square x, that will be equal to 1 minus sine square x, and from here if I want to find what is sine square x, that will be 1 minus cosine square x. So I am going to do that. So I start with the cosine square x minus sine square x, and now I am going to change this. Instead write 1 minus sine square x. Keep the second term as it is, and you can see the parentheses are removed. these two terms combine, so I get 1 minus 2 sine square x. So I have shown the second identity. Now we can go from this step, or we could do it from this step. So I'll do it from here. You can try it later with that one. So again, now we have to show that 1 minus 2 sine square x is the same as 2 times cosine square x minus 1. We are now going to show this one. So again, notice that from left to right, what has happened? We have, on the left we have sine square x term, on the right we have cosine square x. It means the sine square has vanished. So how? We apply the Pythagorean theorem. So left hand side, 1 minus 2 sine square x can be written as 1 minus 2 times 1 minus cosine square x, which is equal to 1 minus, distribute the 2, 1 minus 2 plus 2 cosine square x, and when you simplify it, you get 2 times cosine square x minus 1, and that is what we have. And this is what we call the double angle formula for cosine. That was the double angle formula for sine, and here we have double angle formula for cosine. So what is the double angle formula for cosine? That cosine of 2x is equal to, so whenever you have cosine of 2x, you can write it like cosine square x minus sine square x. Note here, cosine square x plus sine square x is 1, Pythagorean theorem, but cosine square x minus sine square x is cosine 2x. Or it can be written as 1 minus 2 sine square x, or 2 cosine square x minus 1. So the cosine 2x has 3 forms. So we could use any of these depending on our problem. Okay, let's see what we do in 7.3 now.